Hi everyone who's coming along to the Analytics and Data TechCast. We're just kind of going to give it a minute, let everyone get settled. Depending where you are in the world, maybe make yourself a quick coffee and sit back and relax. Our amazing speaker today is Hadi. So welcome to everyone. If you feel free to use the chat or the Q&A, if you're in the chat, feel free to drop me which country you're in. It's always nice to see where our international audience is. As you can probably tell from the accent, I'm representing the UK today, but we've got Hadi in the US. In fact, we were just discussing this, is in Las Vegas, which is pretty awesome. So yeah, feel free, just jump in, say hi. We'd love to kind of build that community bond around everyone. So feel free to say hi. Good, those just joining us, welcome. We are the Analytics and Data TechCast. Today we've got OML usage highlights with Hadi. We're just going to let everyone get settled. I know a few people might just be topping up the coffee cups and just getting the seats ready. Just give it another minute or so and we'll get going. Feel free, drop it in the chat where you're from. Say hi to everyone. Let's create a little bit of a vibe. I can see Washington State represented. I know, New York, Slovenia. Welcome, Slovenia. My side of the world. Costa Rica coming in, great, fantastic. Mexico, cool. Hungary, Budapest. Hi from the UK, hi James, I'm here as well. We've got Austin, Texas, Pennsylvania, nice. Bit of Boston as well, sweet. Hi David, UK, representing the UK, fantastic. Okay, Joe, we'll get going. Keep saying hi in there. We've got other ways for you to communicate with everyone as well. We'll go through those now. But firstly, welcome to Hadi. He's going to be presenting on OML usage highlights, live demo of Oracle Stream Analytics with OML AutoML UI and OML Services. Hadi is an integration specialist with the AppDev and Integration Team at Oracle. He's been working as a software engineer and architect for the past 20 years. Works in quite a few different industries, which is cool. So we've got commercial, aerospace, defense, and telecommunications. Specializing in AI, machine learning, GoldenGate, big data. So I think we're going to have a real cool presentation today and really get into some cool automation work, which is great. I love this part of the ML chain. He holds a bachelor's degree in mechanical engineering and a master's degree in artificial intelligence. So lots of experience in today's presentation, Hadi, so I'm really looking forward to this. We'll just do some quick intros on the A&D community if you've not been with us before. Hadi, can we just get the next slide? Would that be all right?
Can you see my slide, Abby?
Yeah, got it now. There we go. If you are interested, we do TechCasts every other week, but specifically we will have a TechCast days coming up, so we'll tell you more about that in a second. But if you've missed the past ones, I know that I've done one previously, and there's loads of other speakers like Philippe Lyon, and lots of Oracle product managers come to A&D to present. Then check out our TechCast archive. So it's on, you can watch the videos, you can get the slides and really get some interesting information on everything from spatial, graph, machine learning, and OAC. Next slide, please, Hadi. If you're in the US, we also have merchandise available that you can buy. So I get the joy of getting some cool logos and stuff out there. So feel free to pop in and see our store. You can connect to it through our website. Next slide, please. And we love to connect with you. Like I said, feel free, shout out in the chats, chat to each other. but also join our Slack community where you can ask questions, say hi to everyone. There's LinkedIn, Twitter, Facebook, and we have a regular newsletter as well. So if you want to keep in touch with everyone, lots of different ways to connect up with us. Next slide, please. And coming up soon is our winter session, so into 2022, February 15th to the 17th, having a bit of a winter session going on. The 15th is probably going to be our Spatial and Graph Day with Analytics Plus on the 16th and ML Machine Learning on the 17th. So, without further ado, Hadi,
sorry.
Don't worry, my friend. Don't worry. You are the main person today. So, Hadi, I am absolutely delighted to be your host today. Really looking forward to this. I'm going to take a back seat, my friend, and enjoy. Anyone's got any questions, please put them in the Q&A and we'll pick them up at the end. Over to you, Hadi.
Thanks so much, Hadi. Thanks for the introduction and the invitation to analytics and data community. It's really nice to be here and nice to have everyone from around the world. Hopefully someday I'll get to visit all those countries. I've been to a few, but not all of them. So someday maybe. So today I want to go over a couple of kind of introduce you to a couple of applications, stream analytics that we call GGSA and AutoML UI, which is part of the OML Services at Oracle. But I wanted to first touch on how these two applications kind of relate to the idea and concept of data mesh in general, and how that they make that integration possible in a data mesh architecture. Again, my name is Hadi Javaherian, solution engineer and specialist with AppDev and Integration from Oracle. I'll start with kind of idea of what a data product is, how we look at data product, and how it is related to data mesh, data fabric, and principles in general. Over some of the stream analytics features and how that relates to AutoML and UI integration, and show you a nice demo of these two products, and I'll touch on a data mesh in the process as well, and then maybe we'll stop for some Q&A. So many have been writing about this emerging software trend impacting data integration software. So Forrester has coined the term enterprise data fabric to describe a modern approach to data management. Gartner also has written quite a bit about data fabric, and also ThoughtWorks, this is a consulting company kind of aligned to agile development and microservices, has spearheaded an industry push towards data mesh. And again, Gartner has been a leader in noticing the industry trend towards stream-centric data management. At Oracle, we're actually taking this up and very active in this space as well. And of course, many others have noted the hype for service mesh in kind of a fast-moving DevOps area. So I think I want to start with first as data. Data, to look at data as a kind of a capital, not like minerals, oil and gas that you mine, but something you invest in and create that data. And of course, without it, you really can't make the product or deliver services that you have in mind for the consumers. And in general, we kind of look at, there's been many definitions of data mesh, but in general, it's a kind of a data tier architecture to integrate data assets or data products across multiple cloud environments. Think of like data product as the end result that meets your customer expectations, where you actually have to design that architecture to create that data product. So in a kind of a data product type thinking, you want to treat data as a product and not a byproduct. So there's several characteristics that comes with a data mesh. One, it has to be decentralized. Decentralized meaning that it has to conform to multiple cloud services and be able to actually deliver those services in those clouds. The second feature of that, or characteristic of it, would be event ledgers. And these event ledgers have to do with the events and movement of data, whether they be events that come from something like a Kafka, or they have asset consistency with transactions. So event ledgers have to be a big part of a data mesh architecture. And again, polyglot, something that's in multiple forms and shapes, whether again that's IoT events or have asset transactions, they have to be in multiple formats where that format and shape is transparent to the user and the consumer. So, and in data product, typically, in general, it starts with something like a digital noise. Let's say a Tesla car creates thousands of data points every second or so, right? There's a lot of features involved with it, hundreds of features. Some of those features are not necessary. As we move up, we kind of go through the business aspect of it, see what can be consumed, create some data assets from it, and finally, at the top, we come with a data product, which is kind of a commodity that you use to basically conform to what the user want to see. And these data products come in a variety of formats, right? They could be analytics. In this particular session, we want to focus on models that come from machine learning and algorithms that come from machine learning and so on. I want to share that in the demo today. And so in the decentralized data mesh architecture, you have to, it's not like you have a hub and spoke type model. It has to be decentralized. You really need to adopt a decentralized distributed event processing model. Let's say a locomotive that sends thousands of sensor data points to a server. That data has to be captured, filtered, and then processed and go through the transformation if necessary. During that process, run some analytics and then send that data downstream for other consumptions and data products. And this raw data at the source helps create the data product that needs to be consumed. And then we want to look at this kind of thing as operational data versus analytical data. And as I mentioned, one of the characteristics of a data mesh touches on a data pipeline. In this demo that you will see a little bit later, I will refer to two sets of pipelines. One pipeline will act as this training stage for a machine learning model that we want to create. And we're going to use a second pipeline to actually do actual scoring. With some of that data comes in and needs to be processed. So we start with some raw data, then we actually curate that data, prepare that data through that first model, that first pipeline, created a machine learning model, and send that data to AutoML, make sure the model is created, and be able to use that model. And in machine learning, there's something called derived features. In this first pipeline that you will see, you can actually define these derived features that can be used during the learning process and training process, right? That's what we mean by curating and preparing data. And there's also something called unbalanced data set. And so in this first pipeline, you have a chance to actually, make sure that data is correct the way you want it, curate that data, and then generate your model that way. And you will see that shortly in the demo. So our two pipelines that I mentioned run with the Stream Analytics tool. So the tool basically is mainly a UI you see in the center of the screen, and the data, again, delineating the operational data from the source, the sources that come in. That data gets ingested as events, whether it comes from Kafka topics or Kafka Connect, let's say Cassandra or something like that, and JMS topics, GoldenGate, databases, or even file system, gets into the Stream Analytics tool, we apply these patterns. There are a lot of out-of-the-box patterns that come with the tool itself that you actually apply. Create that pipeline. We're going to create a first pipeline to actually do some machine learning training, and then use that model in the second pipeline. So that pipeline gets created in the Stream Analytics in the center there. Once we're done with that, I will show you some stages that are part of the pipeline, these bubbles that you see there. You can send that data down to target, and that downstream target could be a variety of formats. There are multiple formats you could send them to. Data lakes, Hadoop, another Kafka topic, local database, and so on. And so all of these various architectures lead to kind of the great data products, and these are like a variety of formats that a data product can be in. In a data mesh, these data products they're going to be consumed directly by the end user in a variety of use cases. Curated data stream. Business users can expect to receive push notification about change data from source applications. Pipelines that I will show you. These are like very low code pipelines that we can create in Stream Analytics. Dashboards, as you can see, there are a variety of dashboards. These dashboards can be created with time series analytics that actually run down to microseconds as live data is coming in. We are talking about events in live streaming data. They come in real time. You can apply analytics to it, time series. And then, of course, machine learning and scoring on the top right is something that we want to focus on today, how we can actually use AutoML UI as part of OML Services to be able to create that model fairly quickly. Let's listen a few minutes, fairly quickly with some data that we created in the pipeline, and then be able to actually access that model through REST API. And I will show you that shortly. And again, for AutoML UI, as part of OML Services, there's also an internal pipeline that runs there, which is different than the other pipelines that you will actually visually see. This is internal within OML, AutoML UI. It starts with an automatic algorithm selection. It actually picks a nice algorithm for you. It gives you a variety of options, which machine learning algorithm you want to use. And then it does some sampling. If the data is unbalanced, obviously you can actually take care of that. It will actually have metrics to detect that kind of unbalanced data and do some by doing some sampling. Then it does some feature selection. Feature selection is kind of a huge thing in machine learning. You want to make sure that if you have hundreds and hundreds of attributes and features in your data set, not to use every single one of them. And for efficiency, accuracy of the model, and everything else, AutoML UI will do that feature searching very nicely for you. And then towards the end, it will do some model tuning, so you don't have to do some exhaustive search techniques that you have to do, whether you're doing neural networks to deep levels of neural networks. It will do that for you. It will adjust the hyperparameters. These hyperparameters play an important role when you're creating a machine learning model. So it will do all that underneath the covers through this internal pipeline. Again, you're not going to see that pipeline, but you will see these stages as it's building the model for you. And so finally, you have the model, and then we can take a look at these external pipelines that I mentioned that you will see in the demo as pipelines the first one would be a training pipeline, right? So I'll start with the initial training data set, whatever that data set might be. I'll explain what that example, the scenario that I worked on. You need to start with the initial data set. You basically enrich that data set however you want to. You can add derived features to it that might be necessary to create that model. The data might be unbalanced. You can, maybe if you have 200 attributes, maybe you don't need to use all the 200 attributes. maybe trim them down to 20 attributes, enrich that data, then send that data to AutoML UI, something called create experiment. AutoML UI will grab that data, generate a machine learning model in the database itself, right, and through some proxy with Python, and then deploy that model. You can deploy that model, and that model is available for you as OML services that you can actually call through REST API. Then we have a second set of pipeline that we'll create. This is actually will be the actual pipeline that your business analyst, your data scientist is actually interested in. We start with another different set of data sets. That data set could be a locomotive data, Tesla data, or some kind of IoT data. As a feed, it comes in, thousands of records every second or something. Then Spark streaming underneath built within Stream Analytics does some data processing and transforms that data as live data is coming through. And that pipeline, again, this is a pipeline that you actually create yourself. Your data scientists and business analysts can create that pipeline as the live data is coming in. Then we get to the stage where we want to actually call the OML services through REST API, and the model that we just created earlier, right? And we call that model, and we do some scoring in that model and apply that to some analytics and the live streaming data, do some post-processing, whatever might be necessary to actually do some more curating and preparing of that data. And then finally send that data downstream to our target. And again, those targets are databases, Hadoop, Hive, the Kafka topics, and so on, JMS, and things like that. So that's sort of the premise of how these two data pipelines are going to help us integrate these two for creating these data products. So to set the stage, again, this is the same slide you saw earlier, but specific to the scenario that I want to show you in the demo. To set the stage, we have a scenario where our customer is a company that owns and runs vending machines all around the world, right? So these vending machines actually send data at the edge through these IoT sensors. And based on that data that comes in, we would like to predict, our vendor wants to predict when these machines are likely to malfunction, or possibly their vending machines, right? Are they going to go out of stock or below the stock level, right? So as I mentioned earlier, this IoT sensors through the scoring pipe, through the training pipeline, not this the sensors, but the initial data that we want to train the model with comes in from on top through data ledgers, right? Goes through Stream Analytics. We curate that data, prepare that data, enrich it, send that training pipeline, send that data to a target, and our target is Autonomous Database, Oracle Autonomous Database, where OML services run with AutoML. We create that model, and we'll show you that shortly. We create that model, then this actual IoT sensor data from the vending machines will come in, many per second, they will come in. We create another pipeline. Obviously, I've already created that pipeline. Curate that, and then use the scoring through the scoring with the machine learning model that we created. Send that data downstream, right? To send that data to a Kafka topic. As you can see, variety of targets that are available here. In this particular case, it would be Apache Kafka. And so we send this data for the machines that require maintenance to the maintenance team. And the maintenance team can tap into that Apache Kafka and go to the site to that particular machine, take care of the error, whatever it is machine possibly running hot, not cooling enough, take care of that, fix that machine, repair it, or another team needs to stock that machine. It's below stock the vending machine, and basically create another event, another record, which actually will then go back to the system, the database that we know when was the last time it was repaired. So let me then switch to my demo environment. And here it is. This is Stream Analytics. It's basically a UI. There's a Spark obviously running in the background, and Kafka. And so here, what's something we call pipelines, right? So these are all pipelines. Well, the first pipeline I mentioned, there are two pipelines that run there. The first pipeline is going to be a training pipeline, right? I click and then it looks like I'm timed out. Let me just log back in. So yeah, I'll start with the, oh, sorry, this is not the right pipeline. I want to go to the vending machine training pipeline, right? So I've created this pipeline. This pipeline can be very elaborate, right? Each of these bubbles are called as stages, right? At the beginning of this is the pipeline. We have this raw data, as I mentioned, raw data that comes in about the machine, whatever it is. We want to make sure that we can train the model with this, right? We can train create the machine learning model. The arrows, the dotted arrows, actually represent some vending machine live data that come in. As you can see, if I click on these stages, each stage, this is live data streaming as it comes in. It tells me what the temperature of the machine is, what's the light status, if the status is on, what the description of the error is for the machine. Again, right, this pipeline is just for training purposes, right? What I do here in this stage, I'm going to enrich that data with the particulars about that machine, what type of a machine it is, the kind of static data that doesn't change, the type of machine never changes, right? So I'm going to enrich that data and then enrich that. As you can see, these fields are sort of delineated, but what comes in as live data and what comes in as user-defined data and machine data. So the green would be the live data. Again, just for training purposes. Machine details comes in and in kind of brownish, and then user-defined. I've defined some more features here. As I mentioned, you can have derived features. Then finally, I'm done with that. I'm going to send that data downstream to autonomous database, right? And these are for training purposes. So I have two sets of tables. One that keeps track of the low inventory. Again, notice that I click on this stage and I see the data and the attributes that are particular to that stage. Very, very cool that way. So with the low inventory data, I'm sending it to a Kafka topic, right? To a database in autonomous database. Then my other stage, I want to make sure that I can train the model with a different model for how many days it will take, and this, for a machine to run high, right? To run on a high temperature. A prediction that we can do based on historical data, how many days it will take to machine to basically error out and run high. And this first one would be how many days based on historical data can we predict how many days it will take to machine to go below inventory. So this data gets sent, as you can see it, to autonomous, right? So I send that data to autonomous. Now it's sitting in my autonomous environment, and this is AutoML UI, right, in Oracle Autonomous Data Warehouse. And the way I've done this, I go to AutoML, and this literally takes just less than a couple minutes. I go to AutoML UI, and I can create this model based on the data that I have in here. I can actually look for my data source, and my data source is that I just sent through the other pipeline. We'll find that data source, and again, right here, low inventory, right? Not cooling days. How many days it wasn't cooling? That data is just created with that pipeline, and then name it and define what kind of a algorithm I want to use, what kind of a prediction. Define my prediction parameter, and then I've done this earlier, so I'm not going to actually go through the steps. And then start here, and in a matter of less than a minute, I'll have a model, really cool model that I just created with machine learning. And if I switch to my models, these models are generated already for me. And if I here, look at these models. I go to not the deployment, but the models. And these models have been created. You see low inventory, how many days it takes to go to machine to go high temperature. And what's cool about this is actually AutoML UI will give me options of what type of machine learning algorithm I want to use. Do I want to use support vector machine linearly or not? Do I want to use the neural network or so on? You get 5 different options. I can have more. It gives you more options, or I can have less. Once I'm done with that, again, this takes just literally less than a minute. And then I deploy that. I deploy that model to here, and then it will show me that what I've created here is I'm using support vector machine, not cooling, and low temperature days, right? How many days before it stops cooling, and then low temperature. So I'm done with that. Go back to Stream Analytics. I'll go back to the Stream Analytics. Then I want to be able to use that model. So a second pipeline, as I mentioned, second pipeline. I've created this pipeline, obviously. Again, this is now the IoT streaming data, live data that comes in from my vending machines, right, all around the world. I click on that stage, I get the data for that stage. Again, dotted lines meaning live streaming data, right, and static and solid lines, static data. I enrich that data, right? Again, the data is coming in. I enrich that data. As I go to that stage, notice that I get more attributes because I enriched it. I curated and prepared that data. Then here I have 2 sets of models that are just created in AutoML. One model, it will be how many days it will take for it to stop cooling. And notice at the right side of the screen here, it says this particular machine 401 days or 378 days before that machine stops cooling, right? A prediction that it comes back. Then I can basically filter that data. I want to make sure that I am only looking at the machines that actually their temperatures are lower than 40 degrees. And then if the machines need maintenance today, I want to make sure that they're not cooling enough. They're not cooling enough. I want to send that maintenance right away. It's critical. Maintenance team needs to go right away with this filter at this stage, right? Or in this stage, they're not necessary. They're working fine today. But what is the next maintenance day I want to send maintenance to? Is it in 2 days? Is it in 5 days? 10 days? What is our next maintenance days? What is that date? Send that to our maintenance team. Same thing for low inventory. When is it going to go on low inventory? Another team can go and stock the machine and predict that, send that data to that team, and they can go take care of that. So I think that's basically most of what I wanted to share. Hopefully you like what you saw here. I can go to the Q&A if there are any questions.
Yep, you've got a couple of questions, Hadi. So shall I shout them out for you? Will that help? Cool. We've got one in the.
That'd be great. Thank you.
Yeah, we've got one in the chat from Phil. When will Oracle start using semantic RDF knowledge graphs to incorporate meaning into data fabric?
I'm sorry, what was that?
When will Oracle start using semantic RDF knowledge graphs to incorporate, I think it's meaning, into the data fabric?
That I couldn't answer. I can definitely check with the product team. That's something that I'm not privy to, but I can definitely check with the product team and get back to you. Yeah.
Cool. Okay. Yeah. No, that's great. In our Q&A then, we've got Oracle Stream Analytics supports video streaming and real-time analytics like Kensys video streams. Is that correct?
Unfortunately, I'm not familiar with Kensys. I apologize. Video
it's all right.
but we are very we get quite a bit of nice feedback from our customers. We have quite a few customers that use Stream Analytics, but I'm not familiar with that particular video stream, and so.
No worries. And then our next one is, what kind of ML model is built on the historical data? Is it classification, whether the vending machine runs out of stock, or predicting failure of the machine?
Right, good question. Yes, the scenario that I showed you is specifically regression. We use regression there. Obviously, we can use classifications, and so both ways. And then for each, there are a variety of machine learning models that are available that AutoML UI automatically creates. Again, I didn't touch on this, Abby, but OML Services has quite a lot of other features aside from AutoML UI. OML for Spark, OML for Python, OML for SQL. These are great functionality within OML Services that we provide. This particular use case and data mesh scenario and architecture is really interesting to me and quite a few people at Oracle and externally, because it uses AutoML UI fairly quickly. You don't have to spend too much time on generating model. You know what your model your data set looks like. You curate that data, as you saw in the demo, and quickly get a model so you can go and do your analytics that you want to do, create those data products that you want to create for it to be consumed. The other option, obviously, is you can actually create OML a model with a variety of other functionalities in OML Services, but this is a really quick way to integrate the two applications together. So I really like the way actually they operate together. So
yeah, no,
I answered that question.
No, I'm a big fan of it. I kind of advocate the use of the AutoML in kind of the kind of ADW side, and it's really cool. Like, you can get some really good kind of POCs or pilots, and then it's a starter for 10 if people are new to OML. Or you can even deploy your models and then run them and use REST APIs to call them. So there's loads of functionality under the hood. If you're new to OML, absolutely go and check them out. But it's fantastic to see the two worlds coming together, and the streaming world is awesome as well for the real time. I think with IoT taking off so much, then this is definitely one for the future. Any more questions?
Other questions?
I haven't seen any more questions yet. If anyone's not seen it in the chat, Carrie has very kindly put all of Hadi's links in, so you can get more information on Oracle Streaming, the Autonomous Cloud, hands-on labs. We've previously done hands-on labs in our TechCast days, but there are some ones there. There you go, on screen now. So yeah, cool tech papers as well on the blogs to get reading up on this area. If you're new to it, feel free to grab those links and go further. Okay, can we get the next slide, please, Hadi? And as we said, this is your community. So we're here to help you get the most from your analytics journey, be it in kind of question and answers, it can be presenting, it could be all that sort of thing. So we would love for you very quickly just to give us some feedback on how we best provide these services to you guys. On screen at the minute is, what activities would you like this group to conduct more of, so that we can really make sure we're getting the best for you all. So if you could all answer that, that would be amazing. We do have one more question, Hadi, while that one's up on screen, is how is data collected from vending machines to streams?
Great question. Yes, IoT sensor data. I touched on this a little bit earlier. The data comes to be ingested in Stream Analytics. It can come from a variety of sources. That could be databases. It could be a JMSQ, a Kafka topic, or even file system. So, you know, in this particular case, you know, that streaming IoT data can come from Kafka, you know, Kafka topic, and basically Kafka takes care of the repository and collects that data, and in the background, Spark takes care of that transformation as live data goes through the pipeline itself.
Okay, thank you. We do have a second question for you in terms of our kind of feedback from the community is, if a premium membership required an annual fee, what is the most you would consider paying for it? So if you could all just have a little vote on that, that would be awesome. And while people are doing that, Hadi, we've had one more question come in on the chat. It seems your overall pattern uses a combination of ETL and ELT. Would that be correct? So what you've kind of shown today is a pattern used as a combination of ETL and ELT. Is that a fair summary?
Absolutely, great question. Yes, Abby, yeah, absolutely, great question. Yes, it is actually, but let's say more towards ELT than ETL. In other words, we in C, what we call event processing, continuous events processing paradigm, we try to kind of move away more and more from ETL to ELT, where data is not typically just traditionally gets sent to you know, transforms and then loads, but we actually load and then transform that data with Spark. Great question. Yes.
Cool. Okay, if there's any more questions, shout up now. Hadi, on behalf of the community, thank you so much for that presentation. It was amazing, fantastic. If anyone online is wanting the slides or even to just watch Hadi's presentation again, it will be up to our archives as soon as possible, but the slides we'll make available through the Slack channel. So as I said, get involved, join us in Slack, ask questions, you know, and come and discuss what you've seen today. If not, hopefully we'll see you on the next TechCast Day or the winter series in February, when we'll be doing 3 back-to-back days of Analytics Plus, Graph and Spatial, and Machine Learning. But Hadi, thank you so much for today. Really appreciate that. It was so much to just learn today. That was awesome.
Thank you so much, Abby. Thanks for the invitation, and everyone joining. I hope you liked it. It was an honor to be with you. Thanks so much, Abby.
Thank you.